Hey everyone, and welcome. Today we are diving into the world of inequalities. And I know it sounds like a math class topic, but they are literally everywhere. They're how we talk about things when they aren't perfectly equal, which, let's be honest, is most of the time. You actually use them constantly, probably without even thinking about it.
You know when you're trying to figure out what grade you need on a final, you don't need exactly an 80. You need an 80 or higher. Well, guess what? That's an inequality.
Or how about this one? You're planning something, anything, and you've got a budget. You have to spend that amount or less, right? You're using an inequality to keep your bank account happy.
And yep, every single time you get in a car, a speed limit isn't just one magic number. It's a whole range of speeds you're allowed to go.
You see, life is just packed with these more than and less than scenarios. So today, we're going to learn the language and the rules to handle them like a pro.
Okay, so first things first. Before we can solve anything, we gotta speak the language. Think of these symbols kind of like road signs for math. They tell you exactly what's going on in the relationship between the numbers.
And here are the 5 main ones you'll see. You've got your basics, less than and greater than. Then you have their cousins, less than or equal to and greater than or equal to. Notice they include the number itself. And finally, you have not equal to, which is pretty straightforward. It means it can be anything but that one number.
Now this is actually pretty cool. These symbols are all about perspective. Saying 6 is greater than 4 is the exact same truth as saying 4 is less than 6. They describe the identical relationship. You're just looking at it from the other side.
All right, now that we know the symbols, let's actually get to solving. And here's the good news. If you can solve a basic equation, you are 90% of the way there. The steps are almost exactly the same. But there is one crucial, game-changing little twist. I'm serious. You can add, subtract, multiply, and divide to get that variable all by itself, just like you always have. But there is one specific situation where everything changes. If you get this one rule, you've pretty much mastered inequalities. And here it is. This is the whole ballgame right here. Whenever you multiply or divide both sides of an inequality by a negative number, you must flip the sign. A greater than flips to a less than flips to a greater than. You got to burn this into your brain because this is where most mistakes happen. Let's look at our regular example first. Here, we just move things around. We subtract 2x from both sides, add 15 to both sides, pretty standard stuff. Notice we didn't multiply or divide by a negative, so the sign stays exactly as it is. Simple. X is greater than 26. See? Familiar, right? But now, let's see that big rule in action. We start by adding 39 to both sides. No problem. That leaves us with negative 2x is greater than or equal to 24. Now, to get x alone, we have to divide by negative 2. And the moment we do that, bam, we have to flip the sign. That greater than or equal to instantly becomes less than or equal to. And our final answer is x is less than or equal to negative 12. That one step makes all the difference. So we have our answer, like x is less than or equal to negative 12. But what does that actually mean? See, an equation usually gives you one answer. An inequality gives you a whole universe of answers. And the best way to wrap your head around that is to actually see it. Exactly. The solution isn't just one little dot on a line. It's an entire zone, a whole possibility space. It's every single number that makes the statement true. And that's why we use things like number lines and graphs to paint a picture of the solution.
When we put these on a number line, we use a really simple code. For the strict greater than or less than, we use an open, hollow circle. That's our way of saying the starting number itself isn't included. But for greater than or equal to or less than or equal to, we use a closed, solid dot. That means, yep, this starting point is definitely part of the solution set.
And guess what? That same idea works perfectly when you move to a two-dimensional graph. A strict inequality gets a dotted or a dashed line, which means the boundary line itself isn't part of the answer. But if it's or equal to, it gets a solid line, because every single point on that line is a valid solution. It's the same exact idea as the open and closed circles, just in 2D.
Okay, we've covered the language, the one big rule, and how to visualize the answers. So to wrap this all up, let's just quickly go over the most common mistakes so you can sidestep them and get these right every single time. Here's our little mental checklist. Number 1, and this is the big one by far, forgetting to flip that sign when you multiply or divide by a negative. We've hammered that one home. Number 2 is using an open circle when you should have used a solid one, or vice versa. Number 3 is just, simple algebra mistakes, messing up your terms. And number 4 is just mixing up which way the sign is supposed to point in the first place. Always worth a double check. So at the end of the day, inequalities are this really powerful way of thinking about problems that have more than one solution. This whole idea of finding a space of possibilities instead of just a single point is huge. So I'll leave you with this. Where else in your life, in your work, or in the decisions you make, do you run into problems that don't have just one single perfect answer, but a whole range of good ones? Think about it.